Now let's go, guys, and find out the marginal rate of substitution for a typical CES utility function, which is our utility as a function of x and y is equal to ax to the power of rho plus by to the power of rho whole to the power of 1 over rho. So now, if you want to find the marginal rate of substitution, the marginal rate of substitution is equal to the marginal utility of x divided by the marginal utility of y, and the marginal utility of x is equal to the partial derivative of this utility function with respect to x, and the marginal utility of y is equal to the partial derivative of this utility function with respect to y. So now, when we find out the partial derivative of utility function with respect to x and the partial derivative of utility function with respect to y, then it's very easy to find out the marginal rate of substitution. So let's do it. So first of all, the partial derivative of utility function with respect to x is equal to this one. So now let's take the derivative of this function with respect to x. So it's equal to 1 over rho multiplied by ax to the power of rho plus by to the power of rho whole to the power of 1 over rho minus 1 multiplied by, now let's find out the partial derivative of this inside function with respect to x, which will be equal to rho multiplied by ax to the power of rho minus 1 to the power of rho minus 1. So this is the partial derivative of our utility function with respect to x. So now let's find out the partial derivative of the utility function with respect to y, and it's equal to 1 over rho multiplied by ax to the power of rho plus by to the power of rho whole to the power of 1 over rho minus 1 multiplied by. So now let's find out the derivative of this inside function with respect to y this time, which will be equal to rho multiplied by b multiplied by y to the power of rho minus 1 to the power of rho minus 1. So there are some common terms that we can cancel out them. 1 over rho with 1 over rho, this rho with this rho, and this term will cancel out with this term. So we will remain only with marginal rate of substitution is equal to ax to the power of rho minus 1 divided by by to the power of rho minus 1, and it can be equal to a divided by b multiplied by x divided by y to the power of rho minus 1, or we can write down a divided by b y divided by x to the power of 1 minus rho. Either this term or this term, both of them is okay. So now, if we have a kind of CES utility function that a is equal to b, if we have this types of utility function that our a is equal to b, then what will happen? Then the marginal rate of substitution will only remain with that portion, x divided by y to the power of rho minus 1, or y divided by x to the power of 1 minus rho. So we have the marginal rate of substitution for a CES utility function with this term if a is equal to b. And mostly, in order to make it easier, we assume that in this CES utility function, a is equal to b and sometimes equal to 1. So if a is equal to b and equal to 1, so then this utility function will remain with only this one. U xy is equal to x to the power of rho plus y to the power of rho whole to the power of 1 over rho, which makes easier in order to solve it. So this is it, the marginal rate of substitution for a CES utility function. One thing you should remember that here the marginal rate of substitution for a CES utility function, which is the solution, you see that this marginal rate of substitution depends on depends on how much X and Y we already have. We already have. How much X and Y we already have. So the value of marginal rate of substitution for a CES utility function is not constant. It depends on how much X and Y we already have. So then the marginal rate of substitution will be different in different location of our indifference curve. For example, if we have this indifference curve, suppose this is our indifference curve, this is X and this is Y. If the X and Y is here, for example, this is X11, this is X1, this is Y1, and this is X2 and this is Y2. So it depends on how much X and Y we have. So the value of marginal rate of substitution for CES utility function will change. So if we are here, we have different marginal rate of substitution than if we are here. So if we are in point A, we have different value for marginal rate of substitution than if we are in point B. So finally, the marginal rate of substitution for a CES utility function depends on how much or how many X and Y we already have in our consumption bundle. So see you in the next video in order to solve another questions related to the marginal rate of substitution. Thank you so much guys for watching and hope to not forget to subscribe my YouTube channel. See you next time.